Hello, this is Ms. DB, and in this video we're going to go over how to do some of the problems from the 4.4 worksheet, which is on triangle congruence. We're going to be focusing on two special cases, side, 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 or SSS, and side, angle, side, or SAS. So both of these are postulates that we'll talk about today. You should read pages 242 or 245, or else watch the longer full video before doing the worksheet. All right, so side, side, side is when three sides of one triangle are congruent to three sides of another triangle. And if that is true, if you can find that all three sides are congruent, then you can say that the two triangles are also congruent to each other. I'm trying to find here we go. So if you're going to use SSS to prove that you have congruent triangles, of course, you have to show that all three sides are congruent to each other. So when we do number one here, there's three things that you have to find. You have to find each pair of sides being congruent to each other. So we're going to write down what each of those sides are, and you have to say why we know this is true. So let's first use what is given. It is given that JK is congruent to LK because it's marked. They're both marked with one little tick mark. So you would write that that is congruent by given. And then the second pair that we have given is JM and LM. They are marked congruent, so we write that that is given. They both have two little tick marks on their segments, so that means they're congruent lengths. Now we have to find another pair of sides that's congruent. Well, the only other pair of sides in the triangle JKM and the triangle LKM is this side right here. It's the same side in both of them. If they share a side, then that's the reflexive property. The reflexive property says that if they share a side, if they both use KM, then KM is congruent to KM. That's a K. So therefore, triangle JKM, that's this one here, JKM, is congruent to triangle LKM, which is this one over here, LKM, by side, 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 because we showed that three pairs of sides were congruent. And you'll do the same thing for number two. Now in number two, you'll have to write your congruent statement afterward. So your congruent statement, if you're typing, is going to be, let me type here, that triangle something, 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 so three letters, is congruent to the other triangle. And they actually give you the two triangles up here. So I'll go ahead and put those in. So triangle ABC is congruent to triangle CDA by, and then this is where you have to write, if you have found three pairs of congruent sides, then you'll write whoops, I put it in the wrong spot. Then you'll write SSS here. Capital S, capital S, capital S. There we go. Okay. But you have to put each of the pairs that are congruent and then say whether they're given, reflexive property, or there may be other reasons that they are congruent that you could use. All right, then we're going to talk about side, angle, side. That is when you have two pairs of sides that are congruent to two pairs of sides in the other triangle, and the angle between them is also congruent. So side, then an angle, then another side. The two sides are both touching the angle that is marked congruent to each other, or that we find congruent to each other. So as before, we have to have three things. We have to have two sides, pairs of sides that are congruent, and then we have to have an angle between them congruent. So when we do number 3, 4, you have to have sides, then an angle, then a side that is congruent. You can write given, or reflexive property, or vertical angles. Like in the example here, we use that vertical angles were congruent to say that KPM, angle KPM, would be congruent to angle LPN by vertical angles. So they had the angle congruent to the angle. We use vertical angles a lot to show that angles are congruent. Let's look at number 4. It looks a little more complicated here. and it doesn't have the step-by-step stuff. So we're just going to find a side that's congruent to another side, an angle congruent to another side, and then another pair of sides. And this is triangle K, here's K, J, L, there we go, congruent to triangle L, M, K. So the green one congruent to the blue one here. So let's start with our side. So we can see that we are given that JK, side JK, is congruent to side ML. And that's because that is given to us. They are both marked with one tick mark. Let's do angle next. Side, angle, side. So I'm going to erase my mark so that we can see what angle was. Oops. Do I have my eraser? There we go. So we can see the angle mark. There was a mark on JKL angle and another mark on the MLK angle. So I'm going to write that angle JKL is congruent to angle MLK. JKL is congruent to MLK. That's also given. And that was one angle of this triangle and then the corresponding angle in the other triangle. Okay, now we need another side. So another side of our two triangles, we need to know that either JL is congruent to MK, but that wouldn't be the included angle then, because the angle is touching side JK and side KL. So we need to show that this side is congruent to this side. They're the same side. So we can use the reflexive property to say that KL is congruent to, you could call it LK if you want, or KL again, and they are congruent by the reflexive property. So again, they share a side, so then you're using the reflexive property to say that they are congruent to themselves. Okay, in this section, you're going to say whether or not the pair of triangles is congruent by, oh, I forgot to finish this one up. And then I would say, so by SAS, triangle, and they give us which triangles to use here. Triangle KJL is congruent to triangle LMK. It's like a mini proof. All right, so in this one, you just have to write SSS, SAS, or neither. And if it's neither, explain why not, like angles not included or something like that. So in 5, you might have to use something like vertical angles or reflexive property to find if the other side, since only two sides are marked congruent, but they also share a side that would be congruent. So you decide whether this would be SAS or SSS. It's going to be one of those. In number 6, there's only 2 pairs of congruent sides marked, but we have vertical angles that would tell us that those 2 angles are congruent to each other. So could we use SSS or SAS for that? Now in number 7, we have 2 pairs of congruent sides. We've got this one is congruent to this one's congruent to this one, and we have an angle. However, is the angle that is marked congruent between both of the sides? Is it touching both of the sides? If it's not, then you have to say neither. And then in number 8, you can check and see if it's any of these as well. Okay, number 9, you have to explain the difference between SAS and SSS and how you can tell if one of those postulates can be used to prove 2 triangles are congruent. So use your own words there. Now we're going to do some algebra practice. If they're going to give us a variable to plug in for some of the parts. And we can show that the triangles are congruent if we get either SSS or SAS when we do that. So if we get corresponding parts being congruent, the right parts being congruent. So when we do it, and these are both like the example above, they're going to give us a variable to use, and we're going to plug that variable back in and see if we get 6, 8, 9 just like we did for this triangle. They have to have the same sides in order to be congruent. So let's see, side HF is equal to x, and x is going to be 6. So that's 6. So HF, segment HF is congruent to segment BD because they're both 6. So that's a start. Now let's do segment HG. HG is equal to 2x minus 3, but x is 6. So 2 times 6, oh, not minus 3, plus 3. Whoa. See if I can undo that and get back to where I want it to be. It jumped. It did not come back. Well, I know that HF was equal to 6, so I'll just write it again quick. So HF is congruent to BD. All right. Then we also were working on HG, and we said that HG is equal to 2x minus 3. So 2 times 6 minus 3 is equal to 2 times 6 is 12, minus 3 is 9. And that is the same as DC. So HG is congruent, that's a G, is congruent to DC. And now we have one more pair of sides to show that they're congruent. We need to see what FG is equal to. FG is equal to x plus 2, but x is 6. So 6 plus 2 equals 8. And that's what BC was as well. So FG is congruent to BC. So we can use side, 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 and show that the two triangles are, and you could write this again, that the two triangles are congruent. And then for number 10, you're going to do something similar. You're going to plug 3 back in and see if you get the same side lengths and the angle in between them. And if so, can you use SSS or SAS? In number 11 and 12, it's similar, except we're going to go the other way. We're going to find x that would make these triangles be congruent. So let's see what we already have. We already have this side being congruent to this side. And with the reflexive property, I could say that this side is congruent to itself. So if I could show that 20x is equal to 22x minus 3.6, for that value of x, then those two sides would be congruent as well, and then we could use SSS. So you need to solve this equation. I'll start by subtracting both sides. Subtracting 22x from both sides, and I'd get negative 2x equals negative 3.6, and then you'll divide both sides by negative 2 to find what x is equal to. And that's all you have to do for this problem. For that value, this would be two congruent triangles. And in 12, you already have that this side is congruent to this side, and this side is congruent to this side. So if these two angles are congruent, then you can use SAS. This one's SSS. And in order to find that value, you just set these two expressions equal to each other, solve, and find what you get for x. So subtract 4x from both sides, add 27, and you'll find what your value of x is. All right, well, that should help you out on this. There's 2 proofs at the end. Maybe I should help you with one of these. Number 14 is you're going to do the whole proof on your own, but there's some giant hints here. They tell us that C is the midpoint of this one, AD, and also the midpoint of BE. So it's the midpoint twice. So you'll probably use that given twice. And we have the triangle ABC is congruent to triangle DEC. That's what we're trying to prove. That's what we're going to end up with. Our reason for that will either be SSS or SAS because that's what we've learned. And we have some hints that we will use the definition of midpoint twice and vertical angles once. So if we put down our given and then we use definition of midpoint twice, you're going to be, really, that's all you're going to have to do. and we'll use that twice. And we'll use, it says to use vertical angles once. Now you just have to figure out what is true because of the definition of midpoint twice and vertical angles. And then at the very last, you'll have to decide whether you used SSS or SAS. It'll be one of those two. So write down your given. C is the midpoint of this. And then by definition of midpoint, let's look at the red line here, BE. If C is the midpoint of BE, then what two parts are true? What two segments are equal? BC is going to be equal, the length of BC will be equal to the length of CE. Or we can say that segment BC is congruent to segment CE, because that's what the definition of midpoint says. So let's mark that those two are congruent. And then you'll do the same thing for the blue line, which two segments will be congruent, and those will be another side of each triangle. Now for vertical angles, the definition of vertical angles is that they are opposite each other when you get the X formed. And there's an X formed by this blue line and this red line. So the angles that are going to be marked, you cannot just say angle C is congruent to angle C, because we don't know what angle C means. You have to write that angle, let me erase everything so we can see our points really well. We have angle ACB, that's this angle, that's how you name this angle. Angle ACB would be congruent to angle ECD, or even better would be DCE, because then we have the shorter one first. So DCE is the name of the other angle. Those two angles are congruent because of vertical angles. And then your last step, of course, now that we have that, well, you will have, after you finish this, you'll have that you have two sides congruent, you have an angle congruent to an angle, and then you'll have another pair of sides congruent if you finish this proof up, and then you'll be able to say that the two triangles are congruent, and then you pick whether it's SSS or SAS. All right, now we're done. Have a good day, and let me know if you need any more help.